Hello, linear algebra student. This video is for chapter 1.10. Continue with the resistor network circuits problems. So we have a whole chain of resistor and also like battery connected together, and we want to find out the current that's flowing through them using the Kirchhoff law. Don't know how to say it. So let's see. I will go through. There's 4 loops, so we have 4 unknown. Okay, the current is the same in each of the loop, and then we would just have to figure out that the current that it drive would be driven by the voltage. So the voltage usually flow from, not usually, it should flow from the short line to the long line. Okay, the equation for the left top, so this one, A, would be we look at two from here to so this is from there is a I2, right? So I2 go this direction, but I1 is going that direction, right? So this 2 ohm would be 2 times of I2 minus I1 plus 4 I2 plus 2. Oh, well, actually 4. I2 is this, but I3 is this direction, right? So plus 4. So this basically is 4 I2 minus I3 because it's next to I3. And then the first is 2 I2 minus I1, right? But they multiply it out. And then this 2 I2. And it's equal to 18 because it's from the short one to the long one. Okay. So, and it's the same direction as counterclockwise, so it's positive. So that is the first equation. The second equation is upper right, so we say B. So the first one is 4 times of I3 minus I2. So we go from this one, is the resistor is 4, and the current is I3, but then I2 go opposite. So 4 of I3 minus I2 was here, right? And then I have 6 I3, and then I have I can actually 6 I3 minus I4, because this is I3, but at the bottom this is I4. So you can see that that is actually plus 6 I3 minus I4 for this part. And then I have 1 I3, and then I have 3 I3, and it is equal to the opposite of the 27 flowing in this direction. So out of these 4 branches, the only voltage is negative 27. It's supposed to flow this way, but our counterclockwise signify that the current flow this, so you just say negative 27. Lower right would be ABC, see this one, right? So we would go for which one first? 3I4, so they start from here. 3I4, that's just only things I4 plus 2I4 plus 6. 6 was, this is a 6, but 6I4 minus I3. So this is I4 minus I3 and then times 6. And then come down here, so you would have I4 again, but the neighbor is an I1 up, right? I1 up, and this is I4 down. So 1 of I4 minus I1 over here. So that is the lower right equation. And then the lower left equation would start from 5, would be from here, 5. There's nothing, so it's just 5I1. And then it goes up here 1 times I1 minus I4, right? 1 times I1 minus I4. So that's this one. And then go to the counterclockwise direction is 2 I1 minus I2 because there's this neighbor, the top is I2. So basically this is 2 I1 minus I2. And then there's nothing here but the again the current should flow counterclockwise direction, but because the battery is connected this way, it flow from the short to the long one. So it should be negative 23. So we have this four equation with four unknown. And then if you simplify everything, so let's look at the first one. So I1, I have -2, right? -2. I2, I have 2, 4, and then a 4, so 8. And I3, I have a -4, and it's equal to 18. So that is the A1, the A part. The B part would be upper right. So I would look at how many I1 that I have. I have 0 I1, but I have I2 that is -4, -4. How about I3? I3 have a lot, right? So that's 4 of them, 6 of them, that's 10. And then there is another one, 1 to 11, another one, 14. And then there is a I4 right here, so it's -6 I4. So basically combine all the like terms, so that would be -24. And then C, A, B, C. So this is C, and then this is D, right? So this is D. And so C would be, let's look at, we have a I1 at the end, so we move it to the front, -I1. I3 would be here. There is a -6 I3. There's no I2. And there's a lot of I4 because this is an I4 loop. 1, 2, 3, 4, 5. 5 plus 6 is 11. 11. There's another one, 12. So 12. And then the other side is 0 because there is no battery connected. And the last one, we have one I1 and then another I1. So it's 3. No. Oh, no. This one is also an I1. So 5, 6, 7, 8. 8 I1. And there is a -2 I2. So -2 I2. And that's -1 I4. And it's equal to -23. So we have set up the equation with four unknown. Of course, we use the augmented matrix. And I enter it in the calculator. Is -2, 8, -4, 0, 18. -2, 8, -4, 0, 18. 0, 4, blah, 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 -27. 8, -2, 0, -23. And I do a reduce row echelon of A. And it will become like this. 1, 0, 0, 0, 0, -3. Right? So it's -3. Reduce row echelon using the decimal calculator. 1, 0, 0, 0, -3, 0, 1, 0, 0, what was it? 0.25, 1/4. Well, actually, I should do a decimal, fraction. 0, 0, 1, 0, -5 over 2. And then 0, 0, 0, 1. That's one equation, one solution only, and that's this. And we write with the write each one of the unknown as the current and with the units. So that's how you basically solve it. So if there is a loop, you count everything that is in the loop, including the voltage. So if you have two voltage here, you would count it twice in two different cases. They would be fine because in one case it will be going this direction, and in the other case they go the other direction. So you won't be like double counting them. And then for the current, you always go going the counterclockwise direction. And when there is a common branch between two loops, you want to make sure that you do I1 minus I2 or I2 minus I3 like that. So that's the idea of solving this kind of equation. You basically, the most difficult job is to set up this equation and then simplify them. After that, then you just use the calculator to do them.